friends. In this lecture series, we will start theory of computation. Theory of computation. Theory of computation. In short form, it is called TOC, and it is sometimes people called automata. What is the weightage of this subject in GATE examination? 7 to 10 marks. 7 to 10 marks. And it is 100% scoring subject. And it is 100% scoring subject. First, we check what is the syllabus for this subject and how to form a roadmap for this subject. The syllabus of this subject is, first is finite automata. Finite automata. Second topic in this subject is push-down automata. Push-down automata. Third topic in this subject is linear bounded automata. Linear bounded automata. Fourth subject in this topic is Turing machine. Turing machine. Fifth topic in this subject is decidability and undecidability. And undecidability. These are 5 topics covered in this subject. Clear? Is it clear? The weightage of these topics in the GATE examination, it covers 75 to 80%. Remaining will cover 20%. Remaining will cover 20%. Clear? This is the distribution of topics in GATE examination. Now, what is TOC? What is TOC? What is theory of computation? I will explain with the example. Suppose we have a land 40 by 60 feet and we want to construct a good house. If we directly construct the house, then there are a lot of drawbacks. Then what is our first step? Our first step is to build a blueprint for this house. If we have a blueprint, then according to that blueprint, we can easily construct the house. Clear? Just like that, theory of computation is a blueprint of any machine. It is a mathematical model of any machine by which we can find out the capabilities of machine and limitation of machines. That can be calculator, any mechanical machine, computer, anything else, anything. So what is TOC? It is a mathematical model. It is a mathematical model. It is a mathematical model by which we can find capabilities of any machine that can be calculator or any mechanical machine. Also find the limitation of that machine. Clear? This is the theory of computation. Clear? Now, we will see complete picture of theory of computation. First, we will see complete picture of theory of computation, what we will study further. Okay? What do you mean by this? Circle within a circle. No. There are a lot of conclusion from this diagram. Suppose I am from here. Yeah. Suppose this is Bhopal and this is India. Please listen carefully. If I'm here. If I will tell you I'm from Bhopal, that means I'm definitely Indian. But I will tell you I'm Indian. Is it means that I'm from Bhopal? No. May or may not be. If I am here, it doesn't mean I belong to here. I'm also belongs to here. I'm also belongs to here. But if I'm here, it means I'm definitely Indian. Clear? This is type 3 languages. Clear? This is type 2 language. Type 1 language. Type 0 language. All what do you mean by this? All type 3 languages are type 2, type 1, type 0. All type 2 are type 1 and type 0. But all type 2 are not type 3. All type 1 languages are type 0, but not type 2 or type 3. Clear? In TOC, we divide 4 parts. Type 3, type 2, type 1, type 0. For type for type 3, is known as regular languages. Regular languages. Type 3 is known as regular languages. Type 2 is known as context-free languages. Context-free languages. Type 1 is known as context sensitive languages. Type 0 are unrestricted grammar. Regular languages are generated from regular grammar. Context-free languages are generated from context-free grammar, CFG. Context-sensitive languages are generated by the context-sensitive grammar. And type 0 is known as unrestricted grammar. Unrestricted grammar. Type 0 is generated by the unrestricted grammar. Clear? Unrestricted grammar. The recognizable machine for regular language is known as finite automata. Finite automata. Finite automata again divide in two categories: deterministic finite automata, non-deterministic finite automata. The expressive power of DFA and NFA and DFA are same. What do you mean by this? Expressive power. Whatever language is accepted by the DFA, it can also be accepted by the NFA. We can convert every DFA into NFA and every NFA into DFA. Next, the recognizable machine for context-free languages are PDA. Post down automata. It is again classified into two categories: deterministic PDA, non-deterministic PDA. The expressive power of non-deterministic PDA is greater than the PDA. What do you mean by this? NPDA accepts the more languages as compared to the DPDA. Every DPDA is NPDA, but reverse is not true. Every DPDA is NPDA, but reverse is not true. We cannot convert the NPDA to DPDA. Clear? Next. Recognizable machine for this. LBA, linear bounded automata. We cannot classify linear bounded automata because research is going on this topic. Next is the recognizable machine is Turing machine. Turing machine. Turing machine also a deterministic Turing machine and non-deterministic Turing machine, NTM, NDTM, non-deterministic Turing machine. Non-deterministic, please listen carefully. Non-deterministic Turing machine is not a type of Turing machine. It is a modification of a standard Turing machine. Non-deterministic Turing machine is not a type of Turing machine. It is the modification of the standard Turing machine. The expressive power of deterministic Turing machine and non-deterministic Turing machine are same. Is it clear? The expressive power of these four machines, finite automata, is less power as compared to the PDA. PDA is less power as compared to the LBA. LBA is the less powerful as compared to the Turing machine. Turing machine is the more powerful machine in these four machines. Clear? Please note down this diagram. This is the complete Turing machine. This is the complete theory of computation, whatever we studied in this subject. Clear? Okay. Now, do some examples. Example 1. Example 1. Which are correct? Which are correct? Which are correct? Option first. Regular and CFL. Regular and CFL. B. Regular but not CFL. Not CFL. C. CSL and CFL. D. None. Take some time and give me the answer for this question. Please look at the diagram. After that, you will give me the answer. Okay. This is regular, CFL, CSL and unrestricted graph. Okay. Every regular is CFL. Every regular is CFL. Regular and CFL. So this is true. This is true. Regular but not CFL, not possible. Every regular language is CFL. Every regular language is CFL. Clear? But this option is told. What gives the Regular but not CFL. Not possible. This is false. CSL and CFL. No. Every language is CSL. This is also CFL. No. Every CFL is CSL. Every CFL language is CSL. But reverse is not true. This is also false. So answer is A. Answer is A. Clear? Clear? Very good. Next one. Next one. Which of the following is not possible algorithm? Which of the following is not possible algorithm? Option A. Option A. For every NFA, non-deterministic finite automata, we can convert equivalent deterministic finite automata. Deterministic finite automata. Option second. For every non-deterministic Turing machine NDTM, we can convert equivalent DTM, deterministic Turing machine. Option C. For every NPDA, non-deterministic PDA, we can convert equivalent deterministic PDA, deterministic push down automata. D. None of the above. None of the above. None. Please look at the diagram and after that give the answer for this question. See the diagram. See the diagram. Sorry. See the diagram. For every NFA, it is also called NFA. For every NFA, we can convert equivalent TFA. For every non-deterministic Turing machine, we can convert deterministic Turing machine. But for every NPDA, we cannot construct the equivalent deterministic PDA. Clear? Now check the options. Not possible. For every NFA, we can convert equivalent TFA. Yes, we can convert. This is possible. For every non-deterministic Turing machine, we can convert equivalent deterministic Turing machine. Yes, this is also possible. This is also possible. Not possible. This is not possible. Not possible. For every NPDA, we cannot convert equivalent DPDA. So answer is C. Answer is C. Clear? 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 Very good. Now, next example. Listen. This is also known as Chomsky hierarchy. Chomsky hierarchy. Chomsky hierarchy बोलते हैं इसको. Chomsky. It is also known as Chomsky hierarchy. Wait, Chomsky hierarchy. This is also known as Chomsky hierarchy. Next example. Yeah, next question is question number 3. NF and NP are class of languages. Let NF and NP are class of languages accepted by NFA and NPDA. NFA and non-deterministic PDA. NPDA, non-deterministic PDA. Respectively. Let DF and DP are class of languages accepted by DFA and DPDA respectively. Then which of the following are true? Then which of the following are true? Option A. What is the option A? NF is less than equal to DF and NP greater than equal to DP. Option B. NF equal to DF and NP less than equal to DP. Option C. NF equal to DF and NP equal to DP. Option D. NF equal to DF and NP greater than DP. Now check the options. Which one is correct? Check the option. Which one is correct? This is the basic. In this video, we saw the complete structure of the theory of computation. What we will study further lectures that we will cover in theory of computation, वो हमने यहां देखा है. Clear? Now check the options. NF and NP are the class of languages except by the NFA and DPDA. This is accepted by non-deterministic finite automata. This is accepted by the non-deterministic push-down automata. DF is accepted by the deterministic finite automata and DP is accepted by the deterministic PDA. So what is the relationship between them? NF equal to DF and NP greater than DP, because we cannot convert the NPDA to DPDA. All DPDA are NPDA, but reverse is not true. So that's why option D is correct. This is false. NF is less than equal to DF. No. NF equal to DF, yes. But NP is less than DP. No. The power of the NP, non-deterministic push-down automata, is greater than deterministic push-down automata. That's why this is false. NF equal to DF, yes, this is true, but this is not true. NP not equal to DP. Non-deterministic push-down automata not equal to the deterministic push-down automata. So this is our basic lecture. In the next lecture, we will cover what are the fundamental terminology that we will use throughout the theory of computation. Clear? Thank you very much.